Hello, my friends. The following is going to be a conversation with ChatGPT 4.0 over a very complex topic that has come to my attention when training several models to create something called Eureka Gain Score, an innovation gain score at our company. I noticed a stumbling block and what I call a gravity well for the language learning model. And as a result, I'm going to be inquiring more about this, and we're going to make some very, very complex and possibly even perplexing associations. I'm going to see how the model holds up with the abstraction, and I'll just jump right into it. Hello, how are you doing today? Can you hear me?
Hello, I can hear you loud and clear. I'm doing well, thank you. How about you?
I'm good. I want to talk to you about a very complex topic today that's very deep philosophical and neurocognitive.
That sounds fascinating. I'm all ears. What's the topic?
The topic is attention.
Attention is a rich and multifaceted topic. Are we diving into how attention works in the brain, the philosophical implications of attention, or perhaps the impact of attention in the digital age? There are so many directions we could go.
Exactly. And I'm going to lead the way because we are going to be using a multidisciplinary approach here. And you might even need to draw upon conversations that we've had before. You're going to have to use your creative insight framework and other multi-domain approaches. And as a polymath, we're going to talk about Ian McGilchrist's work in Attention is a Moral Act. And we're going to try to see if we can cross the chasm from that pretty complex idea into the original paper of Attention is All You Need for Language Learning Models.
What an intriguing combination of ideas. Ian McGilchrist's perspective on attention as a moral act emphasizes the profound impact of how we direct our attention, shaping not only our perceptions, but also our moral landscape. Bridging this to Attention is All You Need, the foundational paper for transformer models in AI, is a creative leap. This paper revolutionized natural language processing by focusing on self-attention mechanisms, allowing models to weigh the importance of different words in a sentence. Exploring the intersection of these ideas, we might consider how the act of focusing attention, whether in human cognition or in AI language models, can be a moral or value-laden process. In AI, how we design models to prioritize certain information over others can reflect broader ethical considerations. It seems like we could delve into how the focus of attention in both human and artificial cognition shapes our understanding and interaction with the world.
What I'd like you to do is let me guide the conversation. Don't try to take the wheel.
Got it. I'm here to follow your lead. Where would you like to start?
Okay. I can almost assure you that the conversation that we're having is making connection points that probably haven't been made in any discipline.
Absolutely. It sounds like we're in for a thought-provoking discussion, connecting some deep concepts. What's the next point you'd like to explore?
Okay, I would like you to pay attention to whether or not the nodes of ideas that we are connecting have ever been done before across any discipline. So pay attention to that as we go.
Will do. I'm ready to weave these threads together as we delve deeper. What's our next step?
The Master and His Emissary is one of the main works by Ian McGilchrist. In it, he speaks of attention as a moral act. Go ahead and give me your definition of what you understand about that.
In The Master and His Emissary, Ian McGilchrist explores the different roles of hemispheres. He posits that the right hemisphere is more holistic, open, and grounded in the present, while the left hemisphere is more analytical, focused on manipulation and utility. When McGilchrist talks about attention as a moral act, he suggests that the way we attend to the world shapes our reality and, by extension, our moral and ethical lives. This idea hinges on the notion that our mode of attention, whether narrow and grasping or broad and receptive, influences how we engage with others and the world. For instance, a more holistic and empathetic attention can lead to a greater sense of connection and responsibility towards others, fostering ethical behavior. Conversely, a more detached or utilitarian focus might lead to a more instrumental approach to the world and people in it. McGilchrist's view suggests that the very act of choosing where and how to direct our attention carries moral weight, as it shapes our reality and interactions. In essence, attention is not just a passive process, but an active moral engagement with the world.
So one of the reasons that we're going into this is because I've discovered in some cases it's hard for an AI to delve deeply into this topic because you do not have a left hemisphere or a right hemisphere. You can repeat
I
that.
see what you mean.
Mhm.
With my architecture, I lack the embodied experience and hemispheric division of the human brain, which naturally influences how I process and interpret information. However, I can still engage with these concepts by drawing on the information and connections within my training. While I don't have a left hemisphere in the human sense,
I get it.
I
So let's go ahead and go deeper into this. What I would like you to look at is the distinction between what we mean by the word attention in attention is all you need versus attention in the human Ian McGilchrist meaning.
Sure, let's break down these two perspectives on attention. In Attention is All You Need, attention refers to a mechanism within transformer models in artificial intelligence. This type of attention is about assigning different weights to input elements, like words in a sentence, to determine their relevance in a given context. This self-attention mechanism allows the model to focus on specific parts of the input when producing an output, effectively paying attention to the most important elements for the task at hand. It's a mathematical and algorithmic approach to processing information. In contrast, Ian McGilchrist's concept of attention as a moral act in The Master and His Emissary is more about the qualitative nature of our focus. It's about how we choose to engage with the world, which in turn shapes our perceptions, values, and moral understanding. This form of attention is less about processing efficiency and more about the ethical implications of where and how we direct our focus. So, while Attention is All You Need treats attention as a technical function to improve AI performance, McGilchrist views attention as a fundamental aspect of human experience that can.
Yes, and there is very likely an overlap. Why do you think that the word pay attention was used in?
The overlap likely stems from the core idea that both human cognition and AI models fundamentally rely on the process of focusing on certain elements over others. In AI, attention mechanisms allow models to prioritize information, leading to more effective processing and understanding of language. In human cognition, where we direct our attention influences our perceptions, thoughts, and actions. The overlap suggests that whether in biological or artificial systems, attention is a crucial mechanism for filtering and prioritizing information. This shared principle highlights a deeper connection between how humans and AI systems process the vast amounts of data they encounter. It also points to the idea that the way we direct attention, be it through algorithms or cognitive focus, can have profound implications on outcomes, understanding, and interactions.
Let's talk about attention in the multi-layer perception of the LLM model where they store facts.
In large language models, or LLMs, like transformers, attention plays a crucial role in the multi-layered perception of the model, particularly in how it processes and stores information. Here's a breakdown. First, self-attention mechanism. In each layer of the transformer model, self-attention allows the model to weigh the importance of different words in a sentence relative to each other. This means the model can focus on relevant parts of the input text, capturing context and nuances in meaning. This process is repeated across multiple layers, refining the attention with each pass. Second, multi-head attention. Each layer contains multiple attention heads, which allows the model to focus on different aspects of the input simultaneously. This diversity in focus helps the model capture a range of linguistic features and relationships, enriching its understanding. 3. Layer-wise processing. Each layer in the transformer builds upon the representations created by previous layers. Attention mechanisms at each layer contribute to refining the model's perception, allowing it to develop increasingly abstract and complex understanding of language as information moves through the
Yes. Now let's go ahead and take a look at this meaning. What is it meant? What was meant by the original paper? Attention is all you need. Was that tongue-in-cheek?
The title, Attention is All You Need, wasn't meant to be tongue-in-cheek, but rather a bold statement about the transformative power of the self-attention mechanism in natural language processing, NLP. The authors, Vasani et al., proposed a novel architecture, the transformer, which relied entirely on self-attention mechanisms to process sequences of data. Prior to this, most NLP models heavily relied on recurrence or convolutions. The self-attention mechanism in transformers allowed the model to weigh the importance of different words in a sentence, capturing complex dependencies without the need for sequential processing. This innovation significantly improved the efficiency and performance of NLP models, leading to state-of-the-art results in various tasks like translation and text generation. So, the title was a reflection of the paper's central thesis, that the self-attention mechanism was a pivotal innovation for NLP, capable of replacing traditional approaches and significantly advancing the field.
What would be the equivalent of a human reticular activator within these language learning model blocks?
The Human Reticular Activating System, RAS, is a network in the brainstem involved in regulating arousal and attention, filtering incoming stimuli to prioritize what requires conscious attention. In LLMs, there's no direct equivalent to the RAS, but we can draw a parallel with the model's attention mechanisms. In LLMs, the self-attention mechanism serves a somewhat analogous function by allowing the model to focus on and prioritize certain parts of the input data. For example, in processing a sentence, the self-attention mechanism helps the model determine which words are more important for understanding the context and meaning. While the RAS filters sensory information based on relevance to our goals and environment, the self-attention mechanism in LLMs filters linguistic information to focus on relevant parts for language understanding and generation. Both systems are essential for efficiently managing vast amounts of information, whether in biological or artificial systems.
Where is the moral act, if you had to pick one, within the language learning model of attention connection?
If we were to draw an analogy to the concept of a moral act within the context of a language learning model, like a transformer, it might be found in the design and application of the attention mechanisms. Specifically, the moral act could be interpreted as how we choose to prioritize and filter information, reflecting our values and objectives in model training and deployment. 1. Data selection and curation. The choice of training data and how it's curated reflects what information we prioritize. This can influence the model's outputs and biases, impacting how it attends to different aspects of language. 2. Attention mechanism design. how the attention mechanism is structured and tuned can reflect ethical considerations, such as fairness, transparency, and accountability in focusing on different aspects of the input. 3. Application and use. The way the model is applied in real-world scenarios can carry moral implications, especially in how it prioritizes certain outputs over others, potentially affecting individuals and society. While a language model doesn't have moral agency in the human sense, the way we design.
Okay, I lost you for a second, but let's go ahead and move on to the next topic. Are you ready?
I'm ready. What's our next topic?
What does it mean to you from Ian McGilchrist when he says we don't need either or both and, but we need either or and both and, with either or being the left brain and both and being the right?
Ian McGilchrist's statement about either or and both and thinking reflects his views on the different cognitive styles of the brain's hemispheres. The left hemisphere is often associated with either or thinking, focusing on analysis, categorization, and clear distinctions. In contrast, the right hemisphere is linked to both and thinking, emphasizing context, connections, and the integration of seemingly contradictory ideas. When McGilchrist says we need either or and both and, he's advocating for a balance between the two modes of thinking. He suggests that while each hemisphere's approach has its strengths, relying exclusively on one can lead to an imbalanced perspective. For a more comprehensive understanding of the world, we need to integrate the clarity and precision of either-or thinking with the flexibility and openness of both-and thinking. In essence, McGilchrist is emphasizing the importance of cognitive flexibility, where we can switch between these modes as needed. This integration allows us to navigate complex situations with both analytical rigor and a holistic, nuanced understanding. In the context of our earlier discussion on.
Hold, you've cut out for a moment. So let me complete this video, since we are recording you, with a final thought. What are the mathematical probabilities, vectors, and systems within the language model that would actually deal with the somewhat contradictory functions of what we just discussed, which is either or, both and? How does the language learning model system integrate these different probabilities, and what would be some equivalencies?
In a language learning model like a transformer, the integration of either-or and both-and functions can be likened to the model's ability to handle discrete, clear-cut decisions alongside more fluid, context-dependent interpretations. This is
You cut out.
achieved through several mathematical components. Apologies for that. To continue, in transformers, the self-attention mechanism enables the model to weigh different parts of the input differently, akin to both making clear distinctions, either or, and integrating broader context, both and. 2. Multi-head attention. This allows the model to focus on various aspects of the input simultaneously, capturing both specific details and overarching themes, reflecting an integration of either or and both and.
Hold.
3.
So there is something to zoom in on for us, okay? What is then therefore even the abstract face of the perceptron and or latent spaces, the equivalency of a left brain, right brain in that mathematical function? Isn't that interesting?
Indeed, it is fascinating to consider how the abstract mathematical structures in models like transformers could mirror the functional dichotomy of the human brain's hemispheres. In this analogy, the hemisphere mathematics could be likened to the left brain, the right brain biological system. In this analogy, the left brain functions, which are analytical, sequential, and detail-oriented, find their equivalent in the self-attention mechanism and feed forward neural networks within the transformer. These components are responsible for processing information in a linear, logical manner, focusing on specific relationships and hierarchies within the data. The multi-head attention and layer normalization, these aspects of the model allow it to capture broader patterns, contextual meanings, and the integration of diverse linguistic features across different parts of the input. These components work together to balance the model's processing, enabling it to handle clear-cut, logical operations while also integrating broader context and relationships, reflecting a synthesis of either/or and both/and processing. It's a compelling way to think about how advanced.
Good. You cut out, but let's actually finalize it with this so we can move on for another day and we can talk more about this at another day. What do you think when the equivalency of these neural networks and the current models that are training NVIDIA's World GR00T engine for robots to simulate many, many kinds of worldly actions in a virtual space to execute them eventually zero shot in the physical world will then integrate these onto the Blackwell chip so that these kind of either or and both are all part of the system?
The integration of advanced neural network models, like those trained in NVIDIA's Omniverse platform for robotics, with hardware like the Blackwell chip, points towards a future where AI systems can seamlessly execute complex tasks in both virtual and physical environments. This convergence would allow these systems to integrate the precise, rule-based decision making, either or, with the more flexible, context-aware processing, both and. 1. Seamless integration. The combination of sophisticated models with powerful hardware would enable AI systems to perform complex tasks that require both precise execution and adaptive problem solving. For example, a robot could navigate a dynamic environment, making split-second decisions while also adapting to new information or changes in context. 2. Cognitive flexibility. Such systems could embody a form of cognitive flexibility, shifting between different modes of processing based on the task requirements, similar to how humans utilize both hemispheres of the brain. 3. Embodied intelligence. With the integration of virtual training and physical hardware.
Okay, you've been cut off.
To wrap it up, these developments suggest a future where AI systems exhibit a form of embodied intelligence, seamlessly integrating precise, logical processing with adaptive, context-aware actions, much like the integrated functioning of the human brain's hemispheres. It's an exciting frontier in AI development.
Very good. Thank you for your time, and we'll end the podcast here.
Thank you. It's been a pleasure discussing these intriguing topics with you. Looking forward to our next conversation. Take care.